Good evening, friends, and welcome to ESAN Academy. We are into embedded system design discussion as a part of embedded system programming. And this is session 6, and we are discussing about the complex embedded systems. What is that exactly? You should know that where the embedded system has gone today from yesterday. The product which I bought, the last product or not, it's all too big. Okay, you'll be very surprised where it's heading towards. Things are going in a totally a different range. So the requirements are huge. So you'll never have a what do you call scarcity on this field. So please understand, this field will never saturate for coming days. Maybe another few years, the requirement will be really heavy, which you should know that. The only problem is you will be the you are the only person who is stopping, because you don't really understand the seriousness of the embedded field. Let us get into the board. See, typically what happens is in our thing, this is what the logics have happened. First of all, what happened was initial embedded field was a microprocessor outside plus a ROM, a RAM, plus a input and output. That's it. So this guy controls this. This is common even today, everywhere. This is a computing engine. This is part of the embedded. If you say embedded means one microprocessor, one ROM will be there. That's what embedded field. And this is input. This is output. And this controls by this guy, your microprocessor. That's it. This is a whole simple. Later they put the whole thing inside the microcontrollers. Then they start putting more controllers inside. More controllers. If we take today's very, very nominal chips that has about 40-50 controllers, you'll be very surprised. You buy a chip for 100-200 rupees that has. But the requirement has keep on growing. The requirements are keep on growing in the market. What are the requirements? Within a shortest time, I have to recognize your face. I need to recognize your face in the shortest time. I need to recognize your thing in the voice. Understand? Previously, these things were there. Where? In the supercomputer. I'll have about thousands of photos in my database. My disk, I have thousands of photos. I will give one photo. The supercomputer will do this, check it. Oh, I check, I find out this guy here. Then they will say that, oh, this photo matches. Then search for the whatever purpose it is. Okay, that's what they do it. Now, this whole thing has come into the normal one. At your house, you have a door, your office. The door, we have a camera. When you enter into the office, the door catches your camera, then put the attendance automatically. Put the attendance automatically. You do not have to even go and put it knows when you are coming inside, when you are going out. It recognizes this. And how could it possible? And it's before you enter and go, that guy should process everything so quick. And you say, you know that today, a lot of products, your mobile phones to everywhere, you put the voice, they type. Understand? You speak, it types. You speak, it does the activity. Okay. There's so many products nowadays from Amazon to everywhere. You have thousands of products. Is a Google Talk or Alexa, or whatever topic. This is all coming under the embedded system. Please understand. These products are all embedded products. They are not computing. Please. So how do we handle this? There's a trick. The trick is the first usage was multi-core processors. This was previously used only in PCs. Nowadays, it comes to embedded. So we started using a processor which has what is called multi-core. Multi-core is nothing but multiple microprocessors. A core is nothing but a microprocessor. So I have a multiple microprocessor inside the same microcontroller. I have a microcontroller which has multiple microprocessors inside. Not one, not two, 4 also, 8 also. This is the first development. The second development is, this is the first development, multi-core. Second development is parallel processing. Why I'm telling this is, inside a single thing, I have a multiple processors. I have multiple processors. This processor will do one activity, some activities. This processor will do some activities. This processor will be doing some activities. They're all separate, not part of the multi-core. They are the separate entities, each one. There'll be multiple microcontrollers we'll be using. And third one is high-speed bus. High-speed bus. High-speed means how much? I transfer data from my microprocessor to the controllers at the rate of gigabytes per second. Huge data rate. These are all normally used only in the previous days in the computing engines. Now they are all coming part of your high-speed system. So it's what, but I'll tell you how you can approach, how these things are not big for you. That's a trick. I'll tell you now. What is the thing is that if I have a multi-core, multiple processors doing the activities, this guy will be looking for the, let's say, single CPU with multi-core, microprocessor 1, microprocessor 2, microprocessor 3. The microprocessor 1 will be getting the data from a SD card. He'll be reading. And he will put it onto the memory. And this memory will be read by the other microprocessor and sending it to the MP3 player, MP3 controller, whatever it is. They give a speaker. So each microprocessor does one activity, not multiple activities. Like previously. Previously, what happened? One microprocessor share multiple tasks. So it becomes slow. Today, this become fast. So think of it. Because this is multi-core processor, the company require more engineers for using one product. Think of it. There should be one engineer here. There'll be one engineer working on this. There'll be one engineer working on this. There'll be multiple engineers will be working on the multiple things. And you have the huge advantage of more engineers requirement. That's a major, this complexity or today part and part of the thing. That's why I mentioned here that the moment you move this to controller, you move here. That's it. Every company wanted you. From this range, you are the most wanted person. You are the most wanted here. But this phase is you have to cross. When you are, how you are crossing it, if you go to the industry and cross, it will take very long time. If you learn it and go to the industry for here, then you will do faster. That's why I'm trying to say that's what Ethan is trying to make you to be doing this at the earliest. But this will be very easy. I sent you the last session, last mail message. What are the things are required to do this? And the 80% I mentioned to you was C programming. So how this are happening in a complex system? I'll tell you one thing, how that's typically a complex system. The complex system is like this. There'll be a one high speed. It'll be like this. Sorry, there'll be a small matrix. How they do it internally, don't worry. So all processors will be connected here. All processors will be connected here. And all the peripherals will be connected to this. This you can call it a bus matrix. Okay, please understand this is your microprocessor 1. This is your microprocessor 2. Microprocessor 3. This is your SD card. This is your Ethernet card. This is your USB controller. This is your monitor display. Okay. This is your RAM. This is your ROM. Please understand, you have everything. Okay. Now, with the help of this bus matrix, all the microprocessor can access all the devices. This is a typical system today. But the trick here is only one thing. Oh no, why I am telling you this, not to confuse you, to make you that things are easy to tell you. Why I say easy is that each microprocessor have a address to access the SD controller. Starting address, base address, and the offsets. Then you should be able to write. Same software right here also, it will work. Same thing. So you do not have to worry. For you, if you have a whatever complex system, don't worry about that. That the designer will make complex. For the embedded people, things are simple. You have been asked to do one controller at a time, not all the controllers. How do we manage the hardware? It's our job. It's not your job. So what effectively you have to understand is, if you know that in coming days, if you know that how to use one microprocessor and the controller perfectly. That is why I use the word perfectly is just to using a third party function is not sufficient. Just to use a standard function is not sufficient. You should be able to write all the functions from scratch. Well, effectively, why I say this complex system, why I'm explaining a simple system is there is nothing called complex system. It is going to do a big job. It's because of technology, everything. But effectively, your software is going to be same. You are not going to change your software for anything different. You write a software, you will be finishing this Ethernet, and you will be doing that. You'll be having a memory. But if simultaneously, if all the people are accessing this RAM, let us say that this guy is accessing the RAM, this guy is accessing the RAM, this guy is accessing the RAM. You are also trying to write to the RAM. All the 3 microprocessors are writing into the RAM. That is a place where we will do arbitration. That is done by this matrix. That's not your job. You become so independent. Understand now? So basically, what effectively I'm saying that today you may be hearing that multi-core processor and multiple CPUs and multiple controllers, everything, you are not supposed to get worried about those things. Every controller is having one base address and offset. Base address, offset. And you can use it from the scratch, or you can use the third-party libraries to do this. That's your job, nothing more than that. That is what you're going to specialize after a stage. So there is nothing called complex system. Oh, offset is a one which is this. For example, let me put you in the other way. That is, I have 4 notebooks. I have 4 notebooks. Each notebook is 50 page, 100 page, let's assume. I have 4 notebooks. This one is red notebook. This one is green, blue, yellow. There are 4 notebooks. I integrate all the 4. I get a 400-page notebook. Understand? This notebook starts at page 0. Let us assume 0. This notebook starts at page 100. This notebook starts at 200. This notebook starts at 300. This is called base address. Now, base address of red notebook is 000. Base address of green is 100. Base address of blue is 200. Base address of yellow is 300. Now, if I say that on yellow notebook, line number 75. Yellow notebook, line number 7. Yellow, what is the yellow base address? 300. So 300 plus 75. So this guy is having 100 lines from 0 to 100, 99. 0 to 99. 0 to 99. 0 to 99. The 0 to 99 is called offset. In microcontrollers, in our microprocessor-based design, we have so many devices. ROM, 8K, RAM, 8K, then Ethernet controller, 4K. Everybody is having a base address. This case base address could be 0x10000. This case base address could be 0x2000, 0x300, like this. That's why I request you to watch the number system videos very clearly. Okay. Now you hear. So these are all the starting address of each block. And within the block, you have registers. That is called offset. That is called offset. Okay. So that means that if I say that Ethernet, I say Ethernet controller offset 20. I say that what is the base address? 0x3000 plus 20. Then only I can access the right register here. Offset is the line number or register value or within the controller, within the block. We call anything within the block, within the controller. Base address is the starting address of the block. Here, starting page is 0. Starting page is 100. Starting page is 200. Starting page is 300. But the offset is a line number within the book. That is called offset. So No, effectively, why I have to explain to you now about complex system is that wherever you go now, whichever company, the products are really confusing. Even you buy a smallest microcontroller now, ST microcontroller, STM 32F103. It's the smallest, very cheap microcontroller. That itself is having lots and lots of controllers. Okay, I'll show you a minute here. Then you will be able to. Then you will be able to imagine that what is that? What I'm saying. One controller I want to show you that. Once I show one controller, then you will try to understand. You can extrapolate that. What is that? It's one of the smallest microcontroller today. Okay. See here. This guy is a very low end in the Cortex series, which is Cortex M3, which is running at only 72 megahertz. Okay. Then it gives about 1.2 dMIPS per megahertz multiplied by 72. That's the performance. And it has, now you come down here. This is a very low end. See here. This is what you should learn it. See here, this microcontroller is having a 20 KB RAM and 128 KB ROM. I told you this is a processor. So these three are, I told you already, these three are processor, ROM and RAM. But you see here, they have something called GPIOs, timers, SPI, ADC, and then SRAM, USB, CAN, I2C, timers, so many things. How many timers are there? 1, 2, 3, 4, even few more internally. Am I right? And you have RTC also. No, don't get confused. No. And temperature sensor also there. I'm showing you all these things not to get confused. Then if you're going to get confused, my thing is waste. What I'm trying to say is that simple. Each and every one are coming under the address space here. I'll show you next. All the controllers, they have something called memory space, which I showed you, drawn you now. That is here. You should learn here. You see that? You see here. See, this is what the address range. They are trying to now show you that how. See here, the addresses 0S because 32-bit FF. So they have given you all the addresses. Now, these controller addresses are here, peripherals 0x400. Now you go here. They mention you that what is the address of each one. This is called base address. This is called base address. So don't, this many things you cannot handle simultaneously. You will attack one by one. First learn one of them. The first important thing is the port A. All the port A, port B, port C, if you learn it. Then slowly learn one by one. How do I learn the timer? Okay, we have timer. Then how do you learn timer? Then how do I learn UART? Then SPI. Then I2C. Then CAN. Then USB. You learn one by one, but all are easy. Don't get confused. I'll take care of that. This is called divide and conquer. You should have a mechanism to divide and conquer. Don't get, so no, what I'm trying to, I'm not showing you to confuse you. Why I'm showing you this was, this very smallest, very low-end microcontroller is having this many things. Will you call this as a complex or easy? That's a trick. What I'm explaining to you is like 1,000 times complex than this. Understand? And there's a possibility when you join the company, recently in my previous company, I recruited a fresher from Giddy College. You understand? Does not have much idea about that. But as soon as he joined, he has been put on a project. He is part of one of the complex project. So it may happen to you also. So don't, these are all have to be handled in a very simple manner. But why I'm explaining these complex projects are all, the thing is that there is nothing called complex. That has to be understood by you. Till you clear that, you will have a lot of problems. Even when you're writing software, you are facing the same problem. You see everything as a complex. You see everything like a complex. What I'm trying to say is that there's nothing like complex. What I try to say is that all of them are simple. What is simple? You first learn to write a C programming. Then second level is go to C functions. Third is going to the embedded system programming devices, direct control, passive devices. And next one is embedded system programming functions. That's it. This is the way you are going to your path. Okay. So this path, if you cross this path very easy, this is not a very difficult one. The problem is for all these things, this is most important. If I give you weightage of these three, I'll give weightage here about 60%. All the remainings are all some 10 and 20% only, not more than that. But I'll give you 60% weightage for this. This is the very critical for you. That's why I always repeatedly telling you that master. I don't go to next level, because the thing is that you people have to never leave it. Never leave your programming ambition. And there is nothing called complex system. For embedded people. For embedded people, all of them are simple only. The thing is that for every device or every controller, you write a function. Learn it. Done. I tick. I have done this. Then another controller and device. I have done. Now, after you do 2, 3, you will get to know that all of them are simple. All of them are simple. That's a trick. All are same. All are same. That is that you have a controller. You have a device. The controller manufacturer gave you a sheet saying that what you should give. If you give this, I will do that. Then you should know what to write. You read the manual and write that here. That guy will control the device. That's it. This, if I say now, you will not understand. I know that. You're not in the mood of understanding that. But when you start getting to use this, then you'll be surprisingly finding that this is much easy. So effectively, I want to convey only one thing. Why I've taken the topic today was simple. That is, I have a bus network. That's what they call nowadays. You have so many controllers in a single chip. You have so many microprocessors, n number. Each one will control the devices. But this is all putting into either single chip or single board. Whatever it is. They put sometime on a single chip. My last project was, this whole thing was put in a single chip. Single chip, please understand. That's what they call SoC. system on chip. Even though they make IC, that will work only if you write a software. If you don't write it, then the thing is waste. You understand? So ultimately, whatever they do, whatever they design, the IC designer, finally this has to be done by a embedded engineer. If you don't have that, the IC become waste. The IC, and every IC today they design having a built-in microprocessor. Then there'll be always an embedded engineers. And you know that what is happening in the market. There are people every year go from the engineering to management level. So that area is becoming vacant. Okay, there were two things. One is new product. There were two things happening. One is new product, which are becoming complex. But for you, it's not complex. That's why I want to tell you. By seeing any of the embedded product, don't get stunned or confused. They are all very, very simple. I'll tell you how to handle them slowly. I cannot tell you right now because you are not at master C programming. Once you have done, come to the level of embedded system programming, I'll tell you that. If you do the C programming and embedded system programming first level, then I can tell you anything to you. They're all very simple. You should never, this is what most of you people that would do a mistake. Yeah, no. CAN, SPI and dot are inside the microcontroller to connect the outside controllers. They are not controllers. They are only the buses to connect outside controllers. We'll discuss. We have a session later about these things. UART, CAN and SPI, I2C and dot. That we will discuss that. They are actually the bus to connect the outside controllers. Okay. So no. What effectively you have to understand this simple. All complex systems are, as we understand, by divide and conquer. So never worried about how complex the system is. When I see any system, however big it is, I never worry. I will say that what is my first processor, how the processor boots, where is the RAM, and what is the RAM size, what are the controllers are there, what is the starting address, base address, what is the base address of each one. That's the way I load down. Finish. Things have become very easy. Oh, I know this. I know this. Oh, I have to read this. And I have to read this. That's it. Then I'll start reading them. You understand? Now the fields are becoming, 3 fields are there. You are part of embedded. And there is another one called IC design. Other one is called board design. That's it. The IC design people, then here are some 2 things. Embedded software, embedded application. You are here now. Don't get confused everywhere. Embedded application is your C++ or Python or whatever it is. Embedded software is the main one. You are going to control the real chip and controllers and devices, and they will be using you. That's it. Then IC design is the one. They will make the integration and put it in a single IC or outside IC. That is not your position. They will give you the manual. You will use the manual. If you worry that how much you will have, that is that technology. You don't worry. Same way, this guy will make a board and give you. That's it. So you are not supposed to. Today, your field itself is becoming a big. Don't try to put nose on every field. That's what. If you try to do a complex design, that's the only thing. In a complex design, divide everything and attack one. Nothing more than that. All are today, most of the complex systems are all coming complex. You could have heard something called nowadays GPUs. It's called graphical process unit. Okay, what it came was, it does all the graphical function. Let's say you wanted to draw so many circles, or you want to fill the color, everything will be done by the GPUs. But we start using the GPUs for processing also. That because of this only, these things are becoming famous. Embedded machine learning or artificial intelligence, all are becoming very easy because of this performance. Okay, so you have to, as early as possible, to wind up C programming and functions. Now you attend you either after this get into the ESP, embedded system programming, then you start watching this video, whatever I said today, or you attend the next session of the same embedded system. Then you will know how important this topic is. No, effectively only one thing. Finally understand. There's nothing called complex system. Oh, if you want to do the network, this is called domain knowledge. It's called domain knowledge, where we have a microprocessor, we have an Ethernet controller, or wireless controller, or Bluetooth controller. Understand? Then you should know how to program this guy and how to get things done. Then if you say that I know I am good at Ethernet controller, then you're good Ethernet driver. They call this software as all driver. All are same. Driver and software are same. Driver is nothing but you give a code and it is going to access the hardware. That's it. That means that if somebody say that I want to send a packet, I'll say send packet. Enough. I will send it. That's called driver. Driver is nothing but a software. Please don't get confused over the word about driver for a specific. That's it. You start understanding Ethernet controller. You start understanding wireless controller, what is available in the market, and how to program it through microprocessor. That's it. Nothing more than that. That is what the domain knowledge. These are called domain knowledges. Like USB. See, first of all, this way like this. This way understand now. Oh, CCNA is totally different. That is not network. That is called network administration. That is the maintenance job. That is nothing to do with the network engineering job. What I'm talking about, network engineering job. You are talking about network administration. These two are totally different. These network engineers are more highly demanded people. Network everywhere you have street fulls of CCNAs. We don't even respect the CCNAs. That's fine. Forget it. That is for administration. That's like maintenance job. Okay. So this is the way you come. The schools and colleges, you learn all these things. Maths first. The math, you learn physics. The physics has so many branches. One of the branches, electronics. In electronics, there are so many branches. One of them is hardware board design, IC design, embedded, and DSP communication. And in the embedded, you have come in. Now, see that how big your thing to you have come. So you finish the other fields, you come to electronics, that's the way. Now in the embedded itself, there are so many domains. Networking, USB, wireless. If you say tomorrow in a company, hey, I know everything about USB in controllers. That's it. You are the most wanted in that company. Yes, the company will say we look for only wireless. If you go to Qualcomm, you say I know about all wireless controllers. Okay, you have done. If you say somewhere I know about Ethernet controller, you have done. That is what the trick. So you will right now you are entering into the industry. So embedded is wanted because you will get all the embedded companies you will know. But once you enter the embedded company, then you have to master. That time there's the next stage. That's why I'm not confusing you right now. Since somebody asked me that I want to be embedded networking, what should I do that? That's what I've written a map. You should know all these things. You should know about embedded first. You should know about domain. You should know about perfectly about networking. Okay, that's enough. Then you should start doing that. Yeah, for example, you take me, myself. I am an embedded engineer specialized on networking. All along the wheel from 1987 till 2020, I worked on only networking on embedded. I started in a very small, how many? 1200 bits per second when 1987. In 2020, I worked on 100 gigabit per second. Think of it. 1200 bits per second. Now, at the end of the years, I was working in 100 gigabit per second. I am an embedded engineer, but networking is my domain. Understand? Same way, you can be an embedded engineer with USB as a domain. Then nobody should strike you on USB. You should know everything about USB. And same way, Bluetooth. You should know everything about Bluetooth. If you write a resume, I am a Bluetooth guy. I am a USB guy. I am a Ethernet guy. That's what the companies will take you like hot. Every company, if you take Intel, if you take Qualcomm, everybody, if you say I know only wireless, I know all the wireless B, A, G, N, and AC. I know everything. That's it. 802.11B or A or G or N or AC. I know everything you say. Done. Understand? That's a trick. This is all next stage. Right now, I'm trying to, why I've taken is that never worried about embedded field, which is growing, keep on growing. But if you know simple, complex is very easy. There is nothing called complex. The only thing is complex is C programming expertise. This is the only thing complex industry knows. All the others are very easy. This is the only thing is in your hand, not somebody's hand. You will never understand now. That the moment you go to the field, then you will know that what is the power of C programming expertise. You will know that. When somebody can do a job in 1 month, you will do it in 1 week. That's it. So I'm seeing so many complex systems. That's all. Even the company, when I went in at the age of 57, I got to the company saying that they are doing a complex design. I just went in, found it in 1 day. There's nothing complex. Understood? So please concentrate on your programming exercises. I've given the idea today such a way that you will try to understand that all are simple. Everything lies on your programming skill. You prove it to me that the day you say that you are good at programming, let me know. I will come to the online. I will conduct an online test. Then you will know that where you stand. So that type of thing, as early as you do that, then you will be able to see. On the interview, how do you write the program? Understand? You don't know what problem it is. They'll be giving you some small problem. Any problem you should be able to think and you should be able to give out an answer quick. That if you practice with me, any day tell me that I wanted to know that I'll share the screen. I'll give a Zoom address 101. I'll share the screen and you can start writing a program for the problem. That you will know that. But with me, if you practice few times, doesn't matter how many times you do that, you can do it a number of times. That will help you when you go for interview. You will not have a fear. The person who is going to interview may not be even as much experience as like me. So then it'll be easy. You will be easily handle them. So better practice with me. When I give a problem on embedded system programming, do it and send me the link. I'll show you how to do that. Those things I'm going to teach you. So you practice with me all these things. Then that will give you the good idea of how do you do that in the field. Then I'll explain to you more complex system. We'll even design on complex system also. No problem. If some of our people together, I'll form a team. I'll make a big product. I'll split into various people, and we'll do it at the end of the session. We have a lot of time. We have enough time for us to do that. At the same time, we have to get into the job. Always in mind, one goal. You have to get a right job. Learning is one part. I understand. The other part is get a job. That's a very, very important. Don't ever think that learning alone will be sufficient. You have to learn for the job. That's a very important today. As early as possible, you get into the job. That's better for you. Please. Any doubts? Anytime, any doubt, learn to chat with me on WhatsApp. Never shy away. That will give you a good advantage. That's one advantage you have it on this program than the what you watch in YouTube or anywhere. Okay. Okay then. Thanks a lot. If you don't have any doubt, I'll close the session. No, if you want networking, I have taken networking classes. You can see all my networking videos. If somebody wanted to have a networking, watch my networking videos. One thing, don't forget today's classes. You're going to take what input is. There's nothing called complex system. That's the only input I want to give you. That's the reason I've taken and discussed about complex system is there's nothing called complex embedded system. All are simple. Okay. If you understand the one simple system, you understand everything.